Hello children. So today's topic is about coordinate geometry up to straight lines, sets, relations, functions, linear inequalities, and statistics. Okay. Today we first discuss about the synopsis and then problems. So basically first the basic coordinate geometry. So the basic one concept is about the distance formula. If I consider the point P, x1, y1, the distance of the point from origin is, this is x1 comma y1, distance from origin is equals to root over x square plus y square. If it is x1, y1, root of x1 square plus y1 square. Coming to the normal formula, that is A point is x1, y1, B point is x2, y2. The distance between the 2 points is nothing but root over x2 minus x1 whole square plus y2 minus y1 whole square. The next one is about the section formula. So if P is any point which divides the line joining the 2 points A comma P, so in the ratio m is to n internally, then mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n. Coming to the point, if it divides, the point P divides AB line A to P and P to P in the ratio m is to n externally, then mx2 minus nx1 by m minus n and my2 minus ny1 divided by m minus n is a formula. And if P happened to be the midpoint of AB, then I say that the midpoint formula is x1 plus x2 by 2 comma y1 plus y2 by 2. And the next one is about the centers of the triangle. So how about the centroid of the triangle, first one. Next, in center, orthocenter, circumcenter. What exactly the centroid of the triangle means? This is the formula, from the basic one. So it is very simple. Point of intersection of the medians is called the centroid, and the formula is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So sum of x coordinates plus sum of y coordinates average. And what is meant by in center of the triangle? In center means actually the point of internal angle bisector, the point of intersection of internal angle bisector of the triangle. If I take up internal angle, this is internal angle bisector, internal angle bisector, internal angle bisector, they meet at one point. So that is going to be called in center of the triangle. And if the vertices are given to you, so A vertex and B vertex, C vertex are given to you, a formula to calculate the in center is given by this one. Ax1 plus Bx2 plus Cx3 by A plus B plus C, Ay1 plus By2 plus Cy3, where small a is nothing but the side length opposite to the vertex A. Similarly, B opposite to the vertex B, C will be the opposite to the vertex C. And A coordinates are x1, y1, B coordinates x2, y2, C coordinates x3, y3. Then you can calculate the formula. Coming to circumcenter. What is meant by circumcenter of the triangle? So in a triangle, if I consider the perpendicular bisector of the side of the triangle, perpendicular bisector meet at one point. And that point is called circumcenter. With that center, if you construct a circle passes through the vertices, and that is called circumcircle, and whose radius is given by circumradius, and that's called the circumcenter of the circle. Yes, generally. Orthocenter of the triangle. What is meant by orthocenter of the triangle? In any triangle, if you drop the perpendicular from one vertex to the opposite side, so perpendicular, they meet at one point, and that point is called the orthocenter of the triangle. Coming to the next concept is about area of the triangle. So you might have done it already in the lower class. Generally, basic formula is half into base into height. But that when vertices are given to you, A, B, C, then this is actually the formula to calculate. We know we can write in the simplest form, sigma x1 multiplied by y2 minus y3 is a formula to calculate area of the triangle. Okay. And if the area of the triangle is 0, the points are said to be the collinear points. And area of the quadrilateral. When 4 vertices of a quadrilateral are given to you, you can take up x1, y1, x2, y2, x3, y3, x4, y4, x1. Again x1, comma y1 repeated. And then cross multiply x1, y2 minus x2, y1. Okay, plus x2, y3 minus x3, y2 plus x3, y4, x3, y4. Okay, x3, y4 plus y3, x4 plus the remaining part. So that gives you the area of the triangle overall modulus sign. Coming to the next concept is about locus. What is meant by locus? The locus is nothing but actually the curve. The path traced by a moving point under one or more given conditions. So the path of a moving point under one or more given condition is called the locus. Okay, it's called locus. Coming to some of the important points which may save your time in simplifying the problem. In case in any triangle ABC, if the midpoints of the sides are given to you as D, E, F. So the vertex A can be expressed in terms of DEF as. Okay, by completing this triangle, therefore you can see that A, E, D and F is a parallelogram. The midpoint of these two is nothing but midpoint of these two by using the concept A plus D by 2 is the same as E plus F by 2. So from here A can be expressed as E plus F minus D. So likewise the other vertices also can be expressed E plus F minus D and D minus E plus FB and C is E minus F plus D. And the next one important point, the same concept you can apply even for the parallelogram also. Suppose when you take up A, B, C points or vertices are given to you, you may ask to calculate the D coordinates, which is same as the midpoint of these two is same as the midpoint of these two. And that gives you concept of D is equals to A plus C minus B. That's concept. Coming to the next concept about the straight line. So if a straight line makes an angle theta with the positive direction of x-axis, then tan theta is defined to be called the slope denoted by M of the straight line. And theta lies between 0 and pi. Of course, when the slope is equal to 0, that represents a slope of the line coincides with x-axis. When theta is equals to pi by 2, it's a vertical line. It has no slope. Its slope is not defined. Coming to the next concepts, they are nothing but if the two lines are taken with the slopes as m1, m2. Now let me consider m1, m2 are the slopes of the two lines. When m1 is equals to m2, the two lines are said to be parallel. When the product of slopes m1, m2 is equals to -1, the lines are said to be perpendicular to each other. And the slope of line joining the 2 points. Let me take up this is x1, y1 and this is x2, y2. The slope of line joining the 2 points is given by the formula y2 minus y1 by x2 minus x1. Okay, let's revise some of the other points. The equation to the coordinate axis and the lines parallel to the coordinate axis. We know equation to x-axis is y is equal to 0. Equation to y-axis is x is equal to 0. And equation to the line parallel to the x-axis is y is equals to constant, and equation to the line parallel to the y-axis is x is equals to constant. Okay, x is equals to constant, x equals to b, or you can say that. Okay, let's see that. These are the sum of the equations of the straight line. The First one is about the slope form of the equation to the straight line, y minus y, slope point form. It is a straight line which is passing through x1 comma y1, having x1 y1 and having a slope is equals to m. Y minus y1 is equals to m into x minus x1. Second one is a 2-point formula. It is nothing but an equation to a line joining the 2 points x1 y1 and x2 y2. And third one is an equation to the straight line whose intercept on axis is equal to a comma b. If a straight line makes an intercept a on x-axis, y-intercept b on y-axis, its equation can be written as x by a plus y by b is equal to 1, where a comma b are the x-intercept and the y-intercept. And the next one, y is equal to mx plus c, represents an equation to a straight line whose y-intercept is equal to c. A straight line makes an intercept c on y-axis. And the slope of that line is equal to m. Coming to the next one, this represents an equation to the straight line in the normal form. Suppose when I drop a perpendicular from origin to the line, and that length happened to be p, and that is called the normal to the straight line, and if the normal makes an angle alpha with the x-axis, then equation to that particular line is given by x cos alpha plus y sin alpha is equals to p, and this is called normal form of the line. Coming to the next one, if I consider L1 is a straight line a1x plus b1y plus a1 is equal to 0, and L2 is a straight line a2x plus b2y plus c2 is equal to 0, then an equation like L1 plus lambda times L2 is equal to 0 represents a family of lines passing through intersection of L1 and L2. Let's say this is a line 1 and this is a line 2, and this represents an equation to the straight line L1 plus lambda L2. For different values of lambda, you will be getting different straight lines, so that combined together they form a family of lines. Coming to the next one, equation to a line in the general form. A first degree equation in x comma y, that is ax plus by plus c is equal to 0, where at least one of a comma b is not 0 simultaneously. Both of them not 0 simultaneously. That equation represents an equation to a straight line in the general form. And the slope of that straight line is equals to minus a by b, and x-intercept, when I take up x, ax plus by plus c can be written as minus c, and x divided by minus c by a plus y divided by minus c by b is equals to 1. And this is in the form of x by a plus y by b is equals to 1, which is making an intercept of length minus c by a, and intercept on y-axis a length of minus c by b. So x-intercept is minus c by a, y-intercept is equals to minus c by b. By the straight line, ax plus by plus c is equals to 0. Let me consider what is meant by angle between. How do you calculate angle between the two lines? Let's revise the concept. So if theta is angle between the two straight lines whose slopes are m1 and m2, then tan theta is given by m1 minus m2 by 1 plus m1 m2. The same thing if the straight line are given in the form like a general form. This first line is L1 equals 0, second line is L2 is equal 0. They are in the form like a1x plus b1y plus c1 0, a2x plus b2y plus c2 0. Then the corresponding slopes m1 is equals to minus a1 by b1 and m2 is equals to minus a2 by b2. And by substituting the slopes, you are going to have the same formula tan theta is equals to a1 b2 minus a2 b1 by a1 a2 plus b1 b2 formula. And now what is the condition for the lines to be parallel? When L1 is a parallel to L2, the condition is nothing but a1 by a2 equals to b1 by b2. We know the slopes are equal. So it means m1 is equals to m2. That gives you condition a1 by a2 equals to b1 by b2. And when the two lines are perpendicular, you know m1 m2 is equals to minus 1. That simplifies the problem as a1 a2 plus b1 b2 is equals to 0. Coming to the next concepts now. When the two lines are parallel or coincident, when the two lines are coincident, corresponding coefficients of x, y and constants are proportion. a1 by a2 equals to b1 by b2 is equal to c1 by c2. When the two lines are parallel, then I say A1 by A2 equals to B1 by B2 but not equals to C1 by C2. When the two lines are perpendicular, then I say A1 A2 plus B1 B2 is equals to 0. When the two lines are intersecting, their A1 by A2 not equals to B1 by B2. So remember these conditions, so and apply the concepts in the problems to get a solution. Coming to the next one, the length of the perpendicular drawn from x1 comma y1 onto the straight line. This is x1 comma y1 onto the straight line ax plus by plus c equals 0. The length of the perpendicular is given by the formula ax1 plus by1 plus c divided by root of a square plus b square. And the point of intersection of the two lines, a1x plus b1y plus c1 equals 0, a2x plus b2y plus c2 equals 0. A point of intersection means a point which satisfies both the equations is called the point of intersection of the lines L1 equals 0 and L2 equals 0, and a formula given by them is nothing but this one. Okay, right. Distance between the two parallel lines. We know that ax plus by is same x coordinate, x coefficient and y coefficients are there. They differ by a constant C1 and C2. So such lines are nothing but the parallel lines, and the distance between them can be calculated by the formula. So C2 minus C1 divided by root over a square plus b square. Coming to the next, the concurrency of the three lines. Suppose if I consider L1 is one straight line, L2 is another straight line, and if L3 also passes through this point of intersection of L1, L2, okay, then I say that three lines are said to be concurrent at one point. Okay, then what is the condition for the concurrency? You just take up the two straight lines, solve them, and then substitute in the third line. That gives you the condition here. So L1 is nothing but actually A1x plus B1y plus C1 is equal to 0. Similarly, L2 and L3 if you take up, the coefficients alone when you take up and the determinant is equal to 0 is a condition that the three lines are said to be concurrent. That's one condition. Coming to the next, angle bisectors. Angle bisectors, we know that if L1 is equal to 0 is one straight line and L2 is equal to 0 is another straight line. And definitely there would be one acute angle, one obtuse angle. The formula to calculate angle bisectors is nothing but actually this one. A1x plus b1y plus c1. L1 divided by root over a1 square plus b1 square. L2 divided by root over a2 square plus b2 square. And if depending upon the plus or minus, which is a requirement of the acute angle bisector and obtuse angle bisector. This is obtuse angle bisector, acute angle bisector. So this acute angle bisector between L1 and L2, the acute angle bisector, let us say M1, is obtained by with reference to condition if A1 A2 plus B1 B2 is greater than 0, then take the minus sign over here and evaluate, you will be getting what you call acute angle bisector. Otherwise, we will be getting obtuse angle bisector. Or else, you can also calculate acute angle bisector, whether you take a positive sign or negative sign. If you take one sign, one line M1, another line L2, then calculate angle between them as a tan theta formula, and if this is less than 1, that is acute angle bisector. Otherwise, M2 will be the acute angle bisector. That's it. Coming to the next one about the sets and relations concepts. Okay, right. Sets and relations. So what is meant by set? What is a basic one? Sorry, I think we missed out one concept over here. So the concept is about this one is actually the perpendicular bisector formula. It means the equation to the line joining, x1 comma y1, x2 comma y2. And a straight line passing through the midpoint of line joining the 2 points and perpendicular to it is given by this formula. So in other words, you can say that x multiplied by x1 minus x2 plus y multiplied by y. So y1 minus y2 is equals to, it is, you can say that OA square plus OB square minus OB square divided by 2. OA square is nothing but actually A, this is a point, x1 square plus y1 square. OB square is nothing but x2 square plus y2 square minus OB square divided by 2. So the same formula can also be written in this fashion. Now we shall proceed to relations and functions and sets. We know from the lower class the sets concepts, so let me brush up as fast as possible. A set is a well-defined collection of objects is called the set, and the which are objects which are belonging to the set are called the elements of the set. And that a set can be expressed in two ways. One is called a roster form, one is a set builder form. Roster form means listing out the numbers, and set builder form means it is a set defined with the definition. Coming to the next one, if the elements in a set are finite, then it is called a finite set, otherwise it is infinite set. Finite means the number of elements in the set is defined to be the finite. Okay, let me consider the next one. A set with a single element is called a singleton set, and a set with no elements is called an empty set denoted by 5. Okay, denoted by 5. And subset, we know that if I consider as a set notation, if I take up A as a set as like this one and which contained in B, I say every element of A is an element of B. Therefore, I say that A is contained in B. And I say that A is a subset of B. It is entirely inside B. So therefore, I say it is called subset. Suppose it might happen that A can be equal to B also. If it is not equal to, then it is called proper subset. Coming to, therefore, it is called proper subset if it is equal to there. If it is not equal, then I say it is called proper subset. Right? Now coming to the next one, power set. What is meant by power set? So the set of all subsets of the given set is called the power set. For example, if I take up the set A is equal to 1, 3, 5, then form a set which is actually the set of all elements of the set of this A. So null set, set 1, set 3, set 5, set 1, 3, set 3, 5, and set 5, 1, and set 1, 3, 5. These are things. So as we are calculating and the power set in a particular sequence, the number of elements in the power set will always be equals to 2 to the power of n minus 1, where n indicates actually the number of elements in the set A. Number of elements in the set A, and the power of set is denoted by P of A. So if the set has n elements, its a power set has got a 2 to the power of n elements. I'm sorry, this is 2 power n only. 2 power n minus 1 is nothing but actually the non-empty subsets, means we have to remove the null set. That's how we describe about the power set. Coming to the next one is a union of the set. So through the diagram, it will be easy to understand. If I consider the set A and if I take up the set B, set of all elements in A, set of all elements in B, and set of all elements in A and B both. So that is said to be called union of the sets. Means if I take up A union B means set of X such that X belongs to A or B or A intersection B. That is called union of the set. Coming to intersection of the sets means if I take up this A and B, the elements which are common to the set A, set B are said to be intersection A, intersection B. Right? Coming to the next difference of the sets. If I consider the elements of the set A which belongs to set A alone but not in the B, then I say it is said to be called A minus B. So in general, if I take up that in general, if I take up, this is nothing but A intersection B, and this portion is A minus B because belongs to A alone but not B, and this is nothing but B minus A because these are the elements belonging to B alone but not in A, and this is A intersection B. Let's proceed to the next one. Complement of a set. What is meant by complement of a set? Suppose if I consider a set A in the universal set, so set of all elements, or you can say the difference of the set A from universal set is nothing but actually set. That's called complement set. Say for example, in the Venn diagram, when I take up, this is the universal set which I am taking. One set I am taking A. Now the set of all elements which do not belong to A, that's nothing but a universal set minus the set A. That is called actually the complement of the set. Of course, the complement of the complement is nothing but A itself, the set itself. The complement of null set is universal set, and the complement of universal set is a null set. Coming to, these are the De Morgan laws. So the De Morgan laws are very much useful. In the lower class you might have proved already. So just let us revise the concept here. When I take up the union complement, the complement of the union gives us intersection complements. So union will become intersection, intersection will become union in this case. Same way, when you see the difference, A minus of B union C is nothing but A minus B intersection A minus C. At the same time, A minus of B intersection C is nothing but A minus B union A minus C. So therefore, be careful, in case of the De Morgan law, union will become intersection, intersection will become union. Coming to the next Cartesian product. You know, if A comma B are any two sets, okay, then set of all ordered pairs from set A comma set B is defined to be called cross product. Suppose if you have 1, 2 and here A, B, C, the possible ordered pairs are nothing but 1A, 1B, 1C. So therefore 1A, comma 1B, comma 1C. At the same time, then 2A, comma 2B, comma 2C. So 2B, comma 2C. That's how we define what we call Cartesian product. Remember that? In case of the Cartesian, and it is denoted by A cross B. And remember that if the set A contains M elements and M elements, and set B contains N elements, I'd say this is M elements, N elements, then A cross B contains Mn elements. Okay, and of course, when I take up the two sets which do not have any common intersection, means A intersection B is equals to 5. In that case, union of A, number of elements of union is equals to N of A plus N of B. Number of elements in set A plus number of elements in B directly gives us the union. Okay, right. Coming to, when A comma B are not disjoint sets, then these are certain identities which we follow. So one is nothing but union of them is nothing but N of A plus N of B minus N of A intersection B. This is A and this is B. So therefore, now when you take up, this is A which you are taking entirely, number of elements in B entirely you are taking, but there are points which are common points are counted twice, and therefore you are subtracting it once. Same way, when you take up number of elements in A, now from the diagram you can clearly see that this portion is A minus B, this is A intersection B, this portion is B minus A. The number of elements in set A is nothing but A minus B, and A intersection B put together is nothing but this, okay, A. the A, number of elements in A is equals to n of A minus B plus n of A intersection B. And n of B minus A is nothing but n of B minus of n of A intersection B. So from the total, subtract the intersection elements. So the overall, the union is nothing but actually set of elements belonging to A minus B, set of elements belonging to B minus A, and set of elements belonging to A intersection B put together is nothing but union. Coming to relation. So the mainly, what is meant by a relation? A relation R from A to B, okay, is a subset of A cross B. A subset of A cross B, wherein A is in relation with B, A related to B. That is called a relation. Okay, which is always, in other words, I say that it is a relation is a set of ordered pairs. Set of ordered pairs. A comma B belongs to R, where A belongs to A and B belongs to B. At the same time, that A is in relation with B. That is an additional thing which we need to remember it. Coming to this, what is meant by domain and range of the relation. In case when you take up the relation from set A to set B, set of all first coordinates over here is called the domain of here. Set of all elements in the first set, if R is relation from set A to set B, so set of all elements in A in the relation is defined to be called the domain. Set of all in the relation, when you take up the coordinates, R is equals to x1 comma y1 etc. So set of all first coordinates is the domain, set of all second coordinates is called the range of the function here. So let's see that. It is a set of elements in the domain and ranges of the relation. Coming to the next inverse relation. So obviously, so when I take up, for example, if the relation has got ordered pairs A comma B comma C comma D, then inverse relation is nothing but actually set of ordered pairs wherein the ordered pairs just reverse it, B to A and D to C. That is defined to be called inverse relation, right? That means inverse relation is nothing but B comma A where A comma B belongs to R. Coming to the different types of relations which are defined on one set. One is called a relation, reflexive relation. A relation A is said to be reflexive if every element of A belongs to A comma A. For every A belongs to A, so A comma A belongs to A. So that is how we define. Suppose when you take up the set A as a 1 comma 2, then you must have the relation as in the relation 1 comma 1, 2 comma 2 is must. Other elements might exist. That's called reflexive relation. Coming to symmetric relation means nothing but so if R is a relation defined on a set R, and if A comma B belongs to R, B comma A should also belongs to R. Then I say the relation R is defined to be symmetric relation. So whenever A comma B belongs to the relation, B comma A should also belongs to the relation. That's how we define what is called symmetric. Coming to the transitive relation. Suppose A comma B belongs to R, B comma C belongs to R, then A comma C has to belong to R, then it is said to be called transitive relation. Right? Coming to the next one, an equivalence relation. A relation which is reflexive, symmetric as well as the transitive. Reflexive, symmetric as well as transitive, that is called equivalence relation. Coming to the function now. Now a mapping defined from set A to set B is nothing but a relation where that mapping relates every element of A with unique element of B. Okay, with a unique element of B. That's how we define what you call the function here. And the first set is called the domain, second set is called the codomain of the function. And the set of all images of x under f is nothing but actually y equals f of x, and also called and x is called the pre-image of y under f. Okay, let me take up this one. The range of f is a set of those elements of B which appear as the image, of f, the image of at least one element of A, and is denoted by f of A. So let me consider f of A means set of all elements which are related from the set A to the set B, all the elements which are the images of the elements of A, and that is called the range. This is called range, whereas B is called the codomain. Okay, right, remember this. And coming to the next different concepts on the functions, one is called 1 function and 2 function. We know if distinct elements are related with the distinct images, I say it is called 1 function. It's quite obvious directly. It conveys the meaning. What is meant by unto function? Suppose if I consider an element y belongs to B, that must be image of at least one element in A, such that f of x is equals to y. Such mapping is defined to be called unto mapping. For every y which belongs to B, there exists x such that f of x is equals to y. Then I say that the mapping is called the unto. And a mapping which is 1 and unto both is called the bijection. I think it is by mistake it is given. This is 1 to 1 and unto. 1 to 1 unto. A mapping is said to be 1 and unto if it is a bijective mapping. 1 unto, okay, or bijective if it is both 1 and unto, right? Coming to into function, a mapping which is not a mapping which is not onto is called into mapping, and a mapping which is not many to one, a mapping which is not 1 is called many to one mapping. Many to one mapping. Coming to different types of the functions, identity relation. Identity function means f a to b is said to be identity function if f of x is equals to x for every x belongs to A. Then I say f is said to be called identity mapping. And where A is equals to B, definitely, because f is a mapping defined from set A to set B as f of x equals x. So that means whatever be the element in A is related with the same element in B itself, and therefore B is equals to A, have to be B equals to A. Coming to constant function, and whatever be the domain, in the domain, if the range is a singleton set, then I say it is said to be called constant mapping, and that is a fixed element. So identity mapping, identity, f a to b is said to be constant mapping. I hope there is a mistake here. Is a constant mapping. A constant mapping if f of x is equal to k for all x belongs to A. Correct? That's called constant mapping. And what is meant by odd function, even function? Now we know when a function f of minus x is equals to minus f of x, then I say it is said to be odd function. Just for example, we know sine inverse of minus x is nothing but minus sine inverse x. So such mapping is called odd mapping. Then what is even mapping? If f of minus x is equals to plus f of x, then the function is said to be even function. Say for example, x square is an even function. So f of x is equals to x square, wherein when you take up here, f of minus x is equals to minus x taken whole square, which is plus x. So therefore, I would say that a mapping is defined to be even function if f of minus x is same as f of x. Is same as f of x. Continuation, next property of the function is a periodic function. What is meant by periodic function? If there exists a real number t, which is the least positive number, such that f of x is equals to f of x plus t, then I say f is called a periodic function with a period t. Of course, as a period t, then it is also period to f of x. I mean, the f of x plus 2t is the same as f of x plus t is the same as f of x. That means 2t is also period, 3t is also period, n pi nt is also period of the function. Therefore, f of x is a periodic function which has no fixed the periodicity of the function. It may changes depending upon the function. Let's consider inverse function. If f a to b is a bijective function, then then the inverse function exists. Okay, inverse function exists where f inverse is nothing but b to a. F inverse is from b to a. So let's consider the next composite mapping. Composition of a mapping means I say if f is a mapping from a to b, if f is a mapping from a to b and g is a mapping from b to c, then a mapping g circle f is from a to c. So g circle f from a to c exists. That's called composition of a mapping. G circle f of x. Next, there are certain important results which we need to memorize. So one is called actually A cross B and B cross A. If A and B are two non-empty sets having n elements in common, then A cross B is equals to A cross B and B cross A will have n square elements. N square elements. If A and B are two non-empty sets such that n of A is equals m, n of B is equals n, then the number of possible relations that can be defined from A to B is equals to 2 to the power of mn. 2 power mn. Okay, let's see that. And these are some of the results which are very useful while calculations. Hope you understood. F of x is a function. Then half of f of x plus f of minus x is even. Half of f of x minus f of minus x is even is odd function. Thereby, by adding these two, you will be getting f of x. So therefore, if f of x is any function, that is not necessarily be even or odd function. So if f of x is any function, can be expressed as a as an even function and an odd function. Even function and odd function. Right? Coming to some of the other aspects. If A and B are two finite sets such that n of A is equals to m and n of B is equals to n, then the conditions which they follow. The number of functions from set A to set B is equals to n to the power of m. The number of 1 and 2 functions, number of 1 function from A into B is given by npm, number of injections. Number of injections from A to B is given by this one. So while calculating number of 1 mapping, you must check that one, the number of elements in the set A will always be, number of elements in set A will always be less than number of elements in B. Then only it is possible to have npm. Coming to the next one, the number of elements, number of two mappings from set A is equals to the number of ways of dividing m things into n groups so that no group is empty. See, this concept will describe in permutations and combination later cases, in detail. Okay. The number of bisection from set A to set B is m factorial, where m is equals to n or 0 otherwise. So that's how we describe about the number of mappings of 1 onto a number of bisections. So coming to some of the other important things which we require here in case if A to B is a bijection, if f A to B bijection, so a function f A to B is a bijection, then n of A must be is equals to n of B. That means in order to have a bijective mapping, you must have both the sets must be of the same elements. Okay. Okay, similarly, if injective mapping is possible only when n of A elements are less, and surjective is possible only when n of A elements are in more. And definitely if it is a bijection, then n of A must be equals to n of B. And 2 power n minus 2 represents actually the number of onto mappings that are defined from set A to set B. Set A consisting of n elements and set B consisting of only 2 elements. So set A consisting of 1, 2, 3 and so on n elements, set B consisting of 2 elements. Each element can be related with either A or B. Either A or B, like that. All the elements can be related in 2 ways each. Such elements are n is 2 to the power of n combinations are there out of each. All the elements related to A must be subtracted. All the elements related to B must also be subtracted. So subtracting it gives us the total number of mappings 2 to the power of n minus 2. Coming to the next one, and these are the some of the important the formulae which is very much useful in simplifying things. And the domain of this function under root is equal to a square minus x square. Please try to remember for all the three, the condition to follow is nothing but if you have a root of something f of x must be greater than or equal 0. If you find 1 by root of f of x, then I say that f of x has to be only greater than 0 but not equal to 0. Okay. Some other results, saving results as follows like this one. Please go through once. Yeah, it's okay. Let's proceed to next statistics, linear inequalities and linear programming it. So statistics, first basic one. So in case measures of dispersion, the first measure of dispersion is nothing but the range. What is meant by range? If you are given a data x1, x2 n3 and so on xn, the difference between the largest data and the least data is defined to be called the range. That is the highest value or the greatest value or the largest, anyway we can say. I say xg and minus of xl. So therefore the greatest observation minus the least observations are the difference is called the range. Coming to the next one, what about mean deviation? Deviation means nothing but actually mean deviation, the name itself says that one, mean deviation. So the mean of the deviations which are taken from either from origin, okay, or from median or from median or from mode. So that is called the mean deviation. It is average of, so the average of the deviations. Let's see, individual series. The mean deviation is given by, if you are taking the data x1, x2 and so on xn, then you would be getting actually the expansion like this. When you if you are taking the deviations from the arithmetic mean, okay, let us say a, then you will be getting the formula like this: sigma x1 minus a plus modulus x1 minus a, modulus x2 minus a, and so on, modulus xn minus a. Coming to this is actually the formula for the, so for the discrete series. How would you calculate the mean deviation? The mean deviation formula is equal to sigma modulus of xi minus a into fi divided by n. Okay, that list is nothing but actually finding the mean deviation. And we shall work out by taking examples later cases. Capital N is equal to f of x is nothing but actually the total frequency. Now, let me consider the next one, standard deviation. The standard deviation referred to as root mean squared deviation about the mean. So, the mean deviations which are taken from the mean only. The standard deviation referred to as root mean square deviations about the mean is called standard deviation. The next one is about the standard deviation for the individual series. This is the formula. And the same formula can be put up in the sigma notations, and it looks like this one. After simplification, sigma is equal to under root of sigma xi square by n minus sigma xi by n taken whole square. Coming to the series, and the same standard deviation formula, just slightly modified with the frequency distribution. Okay, if x1 to xn are nothing but the frequencies, and f1 to fn are the frequencies for the given data. And this is the formula you need to work out when the problem is given. Hope it's clear. Let's see that. And these are certain important points which are related to the theoretical part. Okay, just go through one. The square of the standard deviation is termed as a variance. Hope you understood now. Standard deviation notation is a sigma actually, and variance is given by sigma square. And each of the item is increased by a fixed constant of the standard deviation. Each fixed constant. The standard deviation does not alter. The standard deviation does not alter, or the standard deviation will be the independent of the change of origin. Right? Coming to the next one, these are the formulae which are related with the statistics. For a discrete series in the form a plus d, a plus 2d and so on, which are in arithmetic progression, standard deviation is given by root over n square minus 1 divided by 12. Okay, where n indicates the number of terms. In case of the other the standard deviation for the first n natural numbers is given by root of n square minus 1 divided by 12. Coming to the next one, coefficient of variance. The coefficient of variation is nothing but actually, it is a sigma divided by x bar multiplied by 100. You know, the sigma is nothing but standard deviation divided by the arithmetic mean multiplied by 100. Sigma divided by x bar multiplied by 100, where sigma is called the standard deviation, x bar is the mean of the observation. Now, what is the purpose of this coefficient of variance? This coefficient of variation will give us the observation about the consistency of the given data. So, of the consistency of the data. The more the coefficient of variance, the more the variability. The next thing is about linear inequalities. So what are linear inequalities? An equation or a statement involving less than or greater than, less than or equals to, greater than or equals to is called linear inequality. Of course, what is meant by interval? Set of all real numbers which lies between a comma b excluding a comma b is called the open interval a comma b, like this. Whereas the closed interval means set of all elements which set of all real numbers where every element is lie between a comma b, where a and b are also included in this one. Set of all elements of real number lies between a comma b including a comma b is called the closed interval. Of course, the inequalities, the property of inequality means when we multiplied or when you divide by a same positive number, inequality does not affect. Whereas when you multiply, divide by a negative number, the inequality will be changed. So next one, the graphical solution of linear inequality. Graphical solution means nothing but whenever you are given a linear inequality, let's say for example ax plus by is greater than or equals to c, where c is a constant, then definitely you consider a straight line like ax plus by is equals to c. You draw a straight line and then take up a point either one side of the straight line and check by substituting over here. If that point satisfies that ax plus by is greater than or equals to c, then I say that the point lies on the upper side. Otherwise, the point should lies on the lower side. But this overall in detail we will be going for the explaining about taking example about the graphical solution. Now, this is an example. When I take out a straight line, a vertical line is dividing the space into two halves. One is the right half, one is the left half. And being it is an inclined line, we cannot say right half and left half, but you can say that upper half and lower half. By this context, we will be taking it here, right? So that's about the concepts of linear inequalities. Okay, so take up problems in the next continuation and we'll try to solve it.